Hello and welcome. Today the topic is rendering, and whoops, daisies, we'll be discussing lighting, rendering, CG compositing, and camera and other effects. Or in other words, going from well, perhaps we've already gone from a gray shaded render, just a model, to something that we can render, but there is a whole next step involved in actually getting a final image. And that's sort of the topic for today. So, just to get a little bit of an overview, sort of the size of this, we'll talk about lighting, which is lighting, render wrangling, which is how I like to refer to the process of like just actually doing the rendering and actually like setting that up. We'll talk about the AOVs or CG compositing, uh, and well, we'll sort of get into what that means, but it has to do with sort of splitting up your render into smaller bits and controlling them afterwards in maybe Nuke or Photoshop or something like that. And then a bit of a look at camera and atmospheric effects or things we might want to add to the render after it's done. Or maybe we can do it in the render itself. It sort of depends on where you want to spend your time. And again, there's an expected reading portion to this. So, yep, that's the plan. So let's start with lighting and layout and look dev, and sort of a look at the pipeline, a little bit of just terminology. And so we're clear we're sort of going this way in the pipeline, and just like yeah, a little bit terminology before that is so we have the story and storyboards and all that is 2D, and then animatics happen, and they might be boardmatics, but they might also be previs, 3D previses, and then we'll get a list of, okay, so we need to model this and this and that, and someone will be doing that and texturing it, and someone else will setting the scene up, and that is called different things in different companies, different departments. It might be called layout, it might be called set dressing. I've even seen someone call that look dev. That doesn't seem right at all to me, but whatever, a few different words for basically what happens to set the scene up. Now, in a big show in a big department or company, that might be a big department and like a real like you'll need to spend some time on it. We won't really focus on layout and set dressing as a skill as such in this course. It's more or less implied. But of course, it's an interesting sort of an intersection of sure, you have all these things, these models someone's built, and then you have to set them out and place them and think about composition and things like that. But we will be jumping into lighting. And lighting, when viewed as sort of the place where everything comes together, if we sort of skip over the layout department as a separate idea, lighting is really everything, and it's all about like sure it's the technical work of lighting, but it's also about applying art principles, about thinking about composition. This is often where we when we work on our own projects, this is where we really nail down the camera and all of that. So composition and color and contrast and like all of that. So and just as an example, this is actually taken from a blog. I forget, blue sky feature animation. So like an actual work test to go work at one of the big animation studios can look something like this. Presumably this is for a maybe not a 3D role, but just to think about how much time and effort can be spent on a single scene, but to just decide the lighting essentially. Everything sort of hinges on the lighting, and we want to make sure we should ideally plan our lighting well before we start anything else, because the lighting is sort of the image. This is where the art direction really comes into play. So having like a clear reference, maybe Bob Ross paintings or something, or thinking about the color theory and making sure we have nice color harmonies and all of that. This is the last step where you get to think about that stuff. Well, sort of accepting compositing, but we'll get to that. So apart from having a good plan, I like to suggest that we take inspiration for the lighting process from the real world. I mean, there's a lot of uh, technicalities we could get into when it comes to lighting and rendering and all of that, uh, but um, sort of, and it can get sort of a little bit of abstract that we're just sort of manipulating numbers. But the more real we can keep it, and sort of strive for to think about our lighting the way actual lighters and cinematographers actually work with the diffusers and black flags and all of that. That really quite helps. So I have here three YouTube videos that I quite I there's lots like them. These are a few I sort of like, just showing various ways um, you know people in reality work with lighting to create interesting effects. And when I see something like this, I get inspired for how I do my 3D work. And it's sort of funny when you break this down and you see there's just sort of people standing and waving lights around, and it's quite, I don't know, I find it fascinating. Anyways, so if you're sort of not sure where to go with lighting, lighting tools as such aren't complicated. There's not that much to say. There's a few varieties. There's spotlights, there's area lights. Really, in Arnold, you can do pretty much anything with area lights, and that would be sort of it. So it really depends on like your plan, your game plan, and for that, real world inspiration is to me the golden standard. The next thing to be clear about is color management and like how everything, all of that works. And for that, I'm not gonna talk your ears off. I did so a few uh, lectures ago and in the previous course and all of that. So just to make sure that, of course, before we do any lighting, we need to like know what our color management is doing. Otherwise, we'll just sort of be shooting in the dark and confusing ourselves, no doubt. And well, once we get into lighting, I mean, there's not that much to work with. Like I assume you'll be working with Maya and Arnold lights, so you can sort of make life easier for yourself by ignoring, like you can go in the create menu in Maya and lights, and you have the ambient light and you have the volume light and stuff like that, and that stuff won't actually work. It's for Maya default lights, but not all renderers work with that. So it's just good to be aware that Maya is one thing, but Arnold is another thing, and you can have other renderers in Maya, like RenderMan or V-Ray. And so if you want to make sure that the lights actually work, then just go on under the Arnold tab and lights. And like most of the time, you'll just use an area light, maybe a sky dome light. If you're feeling fancy, mesh light. I've never ever actually used a photometric light. Light portals are just combined with sky dome light, and physical sky is again just a certain version of sky dome with a sort of procedural texture that emulates the physical sky plugged into the sky dome light. So really, it's just air lights, sky domes, and mesh lights, because photometric lights are also just one of the other ones with the texture plugged into it. Okay, so this is pretty much what we have to work with. We can also use emissive materials, but that's not really a lighting uh, tool per se. Sort of mostly used for effect. Lights in CG, though, do come with certain more or less strange options that one can apply. And I suggest you have a look at the lighting in Arnold Maya tutorial, this one, which will sort of introduce things like blockers and barn doors and a few of the other ones here. And like that will tell you most what you need to know. We can also start, well, before I get too fancy. So like blockers being just anything that's used to block light. There's specific tools in Arnold, or like on a certain light, you can add something called a blocker, light blocker. Uh, but also you can just, actually create things, 3D objects, and let them cast shadows. That also works. Barn doors, if you don't know what a barn door is, it's this. These flaps on a light is a barn door, and it's essentially just a light blocker, but sort of a preset version of it. Other things we might do with lighting is we can play with the decay and stuff like that, but I never do that, just leaving everything at quadratic fall off. But just to be aware, like if the light you're shining, if you want to make sure that it doesn't decay with distance, for instance, like if you dig around, you can change the decay, but the default quadratic fall off is sort of the physically correct version of lighting, and unless we have a good reason not to do it physically correct, then do it physically based, which is the default option. Also, like a not physically correct version of doing things is light linking, which is where lights will affect certain objects, but not all objects. Also, sort of a CG hack, not something you can do in reality, but in reality, you can be like really specific with lights and having lots of lights, each for their own individual like, target, which is sort of usually more, well, that's more physically correct and sort of safer to do it that way. So light linking and editing the decay of things, you can do that, and you can add in like really magical light blockers wherever you need them. I tend to stay away from them and just keep things physically accurate, or based, which makes things easier. Something you can do though, and should do every now and then, is adding in gobos or cookies or light textures. So this would be a prime example of a gobo. It's just lights with strange shapes in front, and then you get cool lighting effects. A more subtle version of that is doing, say, image-based lighting, but just with an area light. So you can find online image-based lighting, not for an entire 360 panorama, but just for a single light, which adds a lot more, well, texture and nuance and subtlety than just having a perfect CG light. Really, a lot of work in CG comes down to trying to make things not look CG, and the more imperfect we can make it, the better. And this is one of the key tools to do that. Now, when it comes to the lighting process and like what you're trying to achieve, um, I I sort of leave that to the CG cinematography website. There's a few of these chapters I'd like to read, and that will sort of give you a good foundation, and also give you a nice like naming convention system going. Only odd thing is that I usually put like light or geometry or group, stuff like that. I don't use that as a prefix. I put it as a suffix. But you know, anything that's systematic is good. Anyways, we often find ourselves, um, or maybe the most classical lighting setup you can find out there, that's everywhere. That would be the 3-point lighting, in which you can like find a million tutorials about. And the point of 3-point lighting isn't to do it slavishly, but to realize that all it really has to do with is shaping, and making sure that you can bring out the three-dimensionality of your scene. And this would be an example, like up here. This would be a flat example where the light is just straight on, and you don't really get much shape. Really, it's quite flat. Whereas you know, incidentally, this winds up being more or less a 3-point lighting. We have the key light, we have a kicker and a rim light, maybe two rim lights most likely, and a little bit of a fill, not much fill at all. But we could call this 3-point lighting. But the real point is, we have these cool shadows, we have these cool rim lights, we have a clear separation of objects from one another. Like this just sort of becomes one big surface, but here we really can tell like what's in front of something else. And that's really one of the key goals when doing lighting, is to shape and bring out the shape in objects in an interesting way. But of course, all kinds of cinematography and art direction rules come into play at this point. Bit of a fun fact when lighting is that in a quite recent version of Arnold and Maya, really something called imagers were added in, and you can find out more about it here. But basically, it's under the render settings, or in the you can also find it in the render view window. And basically, we can do stuff like color correction directly in Maya on the renderer. So, maybe we have 10 lights and we realize that we want everything to be slightly more red. We can change all 10 lights, but we can also do like funky color correction on the image, which, well, potentially you could do that to produce the sort of the final look you're going for, but you can also use it to experiment, and maybe you can just sort of dial in a look that you'll later refine, and maybe you'll recreate the same color correction in, say, Nuke, because then you have even more control than you would have in Arnold. But it's nice to have it as a sort of a quick go-to, something you can try out and test. And it's not just color correcting the entire render, there's also like light mixing, adjusting the intensity of various lights after you've rendered, and also adding things like lens and image effects like bloom. And it's not very extensive, but a little bit of a bloom and a little bit of vignetting and stuff like that to sort of help you see how the final image might look. But we're going to talk about compositing as a tool to really finalize the image and not just rely on the 3D render. And now let's talk about rendering or render wrangling. I sort of just like render wrangler. It's a job term or job role in certain companies, and it's simply the person who just makes sure everything renders the way it's supposed to, which can be it can be a task. So let's have a look at that. And number one is before we even start rendering things properly with Arnold, just a few tips on Playblast management. Like this is really extras. You can take it or leave it, but it's a few links for like doing a Playblast. Again, a Playblast is just a capture really of your viewport, so it won't necessarily look very great, but it will be fast. And having decent play blasts and being able to push them out easily and quickly is a pretty neat option. So a few the reason these links are here, like number one, just the default options that come with Maya for the formats that playblasts are saved in, like the actual file format, is sort of sucky, the default options. And this video will show you how to install a little bit of a hack to make sure you can save in QuickTime format, H.264 stuff, and it just sort of becomes better. This is about, well, beautifying your playlist. Not much to say there, just creating better looking playlists. And this one is a little bit of a tip if you've got a camera sequencer setup going for you, so you have multiple lights, multiple cameras in a scene, and you want to play blast all the cameras. Uh, well, well, then that's the video for you. So, yeah, a few play blast tips. Moving on to the rendering process, and sort of just big overview. The general process of rendering will be obviously first the layout has been done and the lighting has been done, and then we'll figure out the output settings. What kind of file do we want? What frame range? We'll optimize the render speed so things don't take 10 hours to render. We might set up additional outputs, so we don't just render one big image. We can also render parts of that image, or render the image in layers, which can make it easier to work with the multiple images later on in compositing, and maybe adding 2D elements and things like that to it, and sort of just finalizing and polishing things and making things look even better, and then doing a final grade. That would be, well, not really the rendering process, but like the final few steps of a project. When it comes to output settings, uh, I don't have that much to say on it. Really, these are the settings I use. Just yeah, EXRs that sometimes half precision makes sense. That would be a 16-bit EXR instead of a default 32-bit EXR, because honestly, 32-bit is a little bit of extreme. It can be useful for some things, like maybe if you're doing, and we'll get to this in a little bit, but if you're rendering motion vector passes and like strange stuff, then 32-bit might make sense. But quite often 16-bit is quite enough, and really, especially if you render HD or even larger, like it can be, well, if you render HD or larger and multiple AOVs, like it can become a lot. The file sizes just sort of balloon, and you have like 40, 50 megabytes per frame. That's easily something that's going to happen to you, and it just, yeah, becomes a little bit of a hassle. So maybe having half precision or 16-bit can be useful. I also quite often try to make sure that I don't render multiple versions. I just overwrite whatever was there before. Uh, Again, just sort of quite often I find, okay, my instinct is to make sure to render a new version, but then it just becomes hard to keep track of, and I never use. Once I've rendered a new version, I don't really ever need to go back, anyways. So yeah, well, you can work any way you like there. Of course, color management comes into play here, and making sure, like, when you save the image, do you want an image that's color managed or the raw image? And if it's raw, then you'll have to make sure, like, if you open that image in something else, maybe like Nuke, then you would want to apply the same color management to it if you want to get the same look. You can also just apply, you know, you don't necessarily have to keep the same color management rules. That would be like in Maya. This mostly has to do with the tone map, because you can read something into Nuke and make sure that's the correct color space, and then you can just color correct it to look the way you want it. That's pretty much what tone mapping does, anyways. It's just sort of a final color correction that's applied to the brightness values of an image. So yeah, these are some of the considerations when it comes to the output. Moving on to optimizing render times. So you'll find that, yeah, renders can slow down. And there's a few things or a few reasons why that might happen. You might, we'll get into it a little bit, but the objects or the geometry itself in the scene can start to slow down. The materials, the type of materials, certain types of materials like subsurface scattering with the wide radius, that can start to slow things down. You can have like lots and complicated big lights that can slow you down, and also the render sampling. So how many rays you really cast out there. So there's, well, these videos are also on my expected reading list, so you'll be checking those out for hands-on tips for how to optimize your scene, get faster, get better and faster renders, and just generally, this is a few tips. Another tip is checking out uh, denoise settings, which you can check out in this video. And finally, maybe this is the big one, but the default setting in Maya for Arnold will be to use the CPU render device, but you can change that to GPU, and things will just work way faster. And pretty much like GPU is being added, support is being added in as we go, and like certain things do not work on the GPU, but most things do. Now, some of these things are actually things that matter to me, like limited AOV support, and then I can find under here. This one worries me, like not having the cryptomat. No cryptomat. Uh, that in itself will mean that I will render my final image with the CPU, because I really want the cryptomat. Maybe I'll work my way around it. But otherwise, like pretty much this I never use. This is just if you're working for tune, shading, and so on. So switch to GPU, and if things don't work, then maybe switch over to CPU again, back to CPU, and well, do that if you need to. Otherwise, GPU rendering is sort of well, quite convenient. As a little bit of a note on render sampling or optimizing renders, like what is that based on? And I think we sort of discussed this in a previous course. But the way renders work is basically to send out a bunch of samples per pixel, a bunch of rays per pixel, and then each of those pixels will, or each of these rays, when they intersect with something, they will send out a bunch of rays out from that point, and maybe even a point, they keep out sending out bounces and try to find a light. And really, what samples in, um, well, what the render samples control gives you is just, well, how many of these extra rays should be sent out, or how many rays per pixel should be sent out. So the number one option, or the number one control over a render, or the render speeds, but also the render quality, is, well, how many samples should be sent out. The other control being how many bounces should be sent out. Like one bounce, two bounces, how many times should a ray bounce before we just give up and it's never reached the light? And that would be the ray depth, essentially. That's what it's called in Arnold. Also in Arnold, we have a few different ray types, and there's the camera uh, sample setting, which is controlling everything. But inside that, we have the diffuse and specular and transmission and stuff like that. And each of those essentially check for a certain material property, like diffuse part of a material, or the specular or metal-like part of a material, or maybe the subsurface portion of the material. So these ray types really sort of exist in their own worlds, and deal with well, each their own material component. Let's talk about the render layers or render setup system. So, and this is a video series that I want you to check out. It's in the expected reading material. And yeah, rendering a complex scene is pretty much what it says. How to, like, basically, this will show you the basic rendering workflow. Um, it's a few years old, but it hasn't really changed in any meaningful way. So that should be good, straightforward. So the basic idea of render setup, or it used to be called render layers. So that's actually a slightly older system in Maya, which was replaced with what's now called render setup. So sometimes you see people refer to it as render layers. Really, what you can do is split up your Maya scene essentially into multiple layers, or really versions of that scene. That's what render setup allows you to do, is to create multiple versions of a scene within that scene. So you can create, and those versions would be called layers. So you can create versions where you override the render settings. So maybe if you want to render out like a really low resolution version that's just for testing things out, then you can save all the render settings, and create an override so it saves the low quality version. Um, that would be one option. You can also create overrides to decide which camera is going to be rendered, which is really useful because if you have multiple cameras in a scene, and maybe each camera has its own frame range that it needs to render, then you can create an override for each camera. And I'm not quite sure if this series goes through precisely that workflow, but this YouTube video here does. So yeah, if you have multiple cameras in a scene, render setup is the way to sort of manage that. And you can also make variants of your scene, showing or hiding certain objects. You can create material overrides and all kinds of things. But yeah, the details will be uh, in that this playlist. But the end result is that you render your scene multiple times and you get, these various outputs. Batch rendering, by the way, is sort of an interesting topic, and like proper studios will have a render farm, and we can maybe at some point look at network rendering, and this like having a proper render management system can become quite handy if you're trying to render a lot of stuff, and it's yeah, it's good to have some system for it. But the basic like workflow in Maya, like just keeping things really simple, is just to find a button that says render sequence and click that button, and it starts rendering the sequence. Excellent, you can sort of see it happening. The problem with render sequence is that it actually happens on the Maya instance or while the Maya instance is open. So you have all these like the memory and the CPU of the computer is being spent to keep Maya open and to render it, and that's sort of a waste. And that's the reason why batch render exists. So if you press batch render instead, an process will start in the background, and you can actually close down Maya, and it will render and sort of spend all your computer's energy on just rendering. So that's a nice one. Um, Fun fact is, if you ever right-click a Maya scene, you'll find a little bit of a menu thing option here called render. So if you have a scene and you need to render it, you don't even need to open it. You can just render, and that will start a batch render. And of course, all the like the render layers set up and everything like that, that will of course be respected also. So that's nice. Also nice, although I haven't actually gotten this to work with Arnold. I just tried it out a few days ago, and I sort of got stuck. It should work. I'm not sure why. Maybe I'm doing something wrong. But it's command line rendering and maybe creating something called bat files. So you don't necessarily have to create bat files, but it just sort of, I used to do this quite a lot. When you don't have a render manager, which we don't, not just set up right now, anyways. Then being able to maybe create a small file, something like this, that basically says, like this is a call to the the executable that's really the thing that does the render for Maya. So this is the render program, and this portion here just sets which project to render, and this says render this scene. And then you can have a lot of more lines and just switch out which scene. So this is scene A and this is scene B, and we could have C and D and E. And what would happen would be like this first scene would render, and then this next scene would render, and then the next scene would render, and then that just keep on going, which is great if you need to render multiple scenes like overnight or something. You don't want to wake up in the middle of the night and check, oh, has my renders finished? Can I now start my next render? You can just create a script like this, and it will render everything straight. And this, like, if you do this and you maybe switch your render to Maya software or something like that, this will work. For some reason, I need to double check this myself. It didn't actually work for Arnold, which is sad, but um, well, such is life. If you need to make it work, talk to me, and I'll be happy to dig a little bit deeper if I haven't fixed it already. And yeah, that sort of covers it. Those are the key aspects of rendering so far. We'll also get into AOVs in just a little bit. I just thought I'd drop in a few more like links, and of course, like rendering, you can get really deep into the weeds and start doing really weird things. So this is from 2017, so like there will be even stranger things, but all kinds of cool tricks being shown in that video. And another cool video, just like if you ever start getting slow scenes and it's laggy and whatnot, then you can check out this guy who creates a forest uh, that renders, and essentially this forest, yeah, consists of this many polygons, which just shows you like what you can do if you make a little bit of an effort. Moving on to rendering with the intent of compositing, and maybe render setup could also come under this category, but we will be talking about AOVs. We won't talk about render layers because we just did, so maybe I don't need to. Hmm. So a single line, excellent. We'll talk about AOVs and CG compositing. And CG compositing then. In the CG cinematography website, there's the compositing article or chapter there, which deals with like why compositing, and a bunch of different reasons for it, and more discussion in that chapter. But it come down, there's various reasons for it. One of them being like 3D render speed. Sometimes it just gets sort of slow, but we can fix things in post, and yeah, that's an option. Another reason is interactivity and iteration. Like render speeds, even if the render speeds are sort of decent, they don't allow for sufficient creativity, perhaps. Another reason could be like we're going for photorealistic integration, then we definitely need to do compositing. But just all kinds of creative opportunities are unleashed once we go out of a 3D software and we start looking at our work as a 2D image, because that's what it is. And it's sort of, yeah, it's sort of a tricky and it's sort of dangerous to work in a 3D application, because you see and you know the 3D scene, but the audience won't. The audience will only know the 2D image. And sort of spending a little bit of time specifically in sort of the same mindset as the audience just helps. And you realize like, oh, maybe I can make this a little bit brighter, and I can just add in layers of things, and they don't have to be perfect 3D things. It's just 2D layers I add in, or maybe I can just paint on top of this. And yeah, those are the sort of things we realize we can do once we jump into compositing. So these first two videos here are videos that you will be checking out through uh, well, the expected reading of this course. Sort of just basic CG compositing, and a little bit of like inspiration, some strange things you can do, and like the same thing but just doing it in Photoshop. This one being obviously in Nuke. I want to give it a little bit of a shout out to this CG compositing series that I think is not even completed yet. It might be by the time you get to this. But Compositing Mentor, which is a fantastic YouTube channel. They've done a few other ones about keying and whatnot, and right, really going deep into it and really detailing everything. And yeah, yeah. So this is a really foundation giving series. It's a bit long or a bit slow, but that's what you get. Like if you want all the nitty ditty, the details. If you want the details, check that one out. Something we can do in Nuke is color correction or grading, and just color correcting the image and making it something more interesting. Reminding ourselves of what is actually the color scheme we're going for in this image, and maybe clarifying that a little bit and bringing it out a little bit more clearly. So if you're not familiar or comfortable with the color correction tools in Nuke, check out this video. And yeah, something else we can do in Nuke or compositing that we really, yeah, gets very tricky to do in Maya is lens effects, lens and all kinds of media effects. And this is another video. I think this is about a 15-minute long video, but it's part of a longer series if you want to like really dig into it. That will sort of talk about the lens and the camera and the various things that we usually like. There's sort of a checklist of things that you get into eventually, and I'll talk more about this myself a bit later in this lecture. But things we'll want to apply to create a more camera realistic image. Of course, something else, it's not really a compositing thing, but things to do after we've rendered something is add audio. Now for AOVs and LPEs. So AOV standing for arbitrary output variables, which I've never found to be a very good name because they're not very arbitrary. The At least not the default ones that come sort of as presets and are easily available. They tend to come into um, two categories, really, maybe three, maybe four. The first one being light or material component. So basically, the final image will consist of a bunch of really sub images of the diffuse portion of the image or the specular portion of the image, and this is the documentation. And I think we can sort of see um, a few versions of it. So the direct portion of light for the diffuse and the indirect portion of the light for the diffuse, and then the same for the specular and the same for the subsurface scattering and so on. The same for all kinds of things. Something else that can be rendered out from Arnold as an AOV are albedo AOVs, which show you not something that's like directly used in the render, or as part of the final image, but it's the sort of the final color as interpreted by the renderer of the diffuse albedo, the color texture. That's really what this shows. The diffuse albedo is basically the color texture, and the same for the subsurface scattering and for specular and all of that. So lighting and material components and albedo, that's also good. And there's also a bunch of utility AOVs. For instance, the ID mask or the ID the ID AOV, which quite often these days I never use the built-in or even create my own ID mask unless it's for a very specific reason. I use the Cryptomat fader, which is an automatic ID mask, object mask, all kinds of mask. It If you're working with Nuke, you don't need to install it, and it's just a really convenient way to be able to use select, like isolate certain parts of the image later on. So that's why Cryptomat is quite useful. There's also a few other AOVs, which I'll get back to in just a little bit. But the basic AOVs and like the most go-to and often used ones would be like the basic lighting and material ones. Good to know about is in some software this might be referred to light path expressions directly, or well, sometimes that would just be called maybe like render layers or something else. But something that's becoming more and more common really is light path expressions, which is basically if you want to create your own AOVs, you can do so using a sort of there's a certain terminology or a grammar for how to write this. So you can isolate exactly the parts of the image that you want, which is a little bit cool, but also quite nerdy. You can get quite far using the built-in AOVs, which is, yeah, built in. And yeah, so when you've set up a bunch of AOVs and you'll be in a render settings menu looking something like this and selecting which AOVs you want and then hitting render. And well, before you hit render, you can select if you want to merge all the AOVs to a single EXR file or if you want to split each to its own file. I pretty much always just merge them so a single file has everything that's needed for a single frame. That just makes sense to me. But that can also generate quite big files, something to be aware of. But then we would bring that, would get all these versions of an image, but all merged into a single file. So the first order of business when working in Nuke or something, it would be to shuffle them out so we separate those, so we can see them each to their own. Maybe using a few various options. I quite like it. This is a small plugin for Nuke multi-channel split that gives you a just a shortcut. I keep forgetting what it is and needing to recheck it whenever I go back to it. But basically, it just takes, if you have a lot of AOVs, and you can have a lot, like you can have dozens of AOVs in a single file, and it sort of becomes a hassle to split them out. This just does it automatically. And then you would start adding effects to it, right? And then merging everything together, and that would be it. Like you would have recreated your beauty render from the basic AOVs, and maybe adding in glows or color corrections and whatnot to just sort of tweak things a little bit further. And a note would be, or like the basic, like most light light path, yeah, AOVs would just be plus. You would add them together because light is additive. That's how it works, and that's the basic workflow would be an additive merge. There's also a version of this where instead of splitting everything out, splitting everything out and then merging it with plus, is you would not split it, but you would, like, maybe you would realize you want to affect a certain thing, and then you could split that out, subtract it, edit it, and then plus it, and that would be called a subtractive workflow, or subtractive compositing, which is something you can look up if it interests you. So this would be the basic process of sometimes called multipass rendering, and to rebuild the beauty, which all of this, by the way, is covered in this one. And also, if you would like just a slightly different perspective on the same thing, and maybe a little bit like this one works a little bit quickly and also checks out a few other subjects, so that if that one is a bit confusing, then also have a check at this one, which sort of gives a more, yeah, a little bit of a easier and a little bit slower, and also a little bit fun because it winds up compositing like this robot, compositing it over a photograph, which is sort of fun and something we will be doing more in a later course. We won't really work against a photo or a plate in this course. We'll just work entirely 3D. But of course, if we start working with film, then that workflow becomes very important. Now, as I mentioned, there's a bunch of additional or utility AOVs you might render, such as the Z depth or the position or the normal. I mentioned the cryptomat. Here's more about the cryptomats and a note for that specific video, and all kinds of things we can do. I won't go into, well, we can also set like the filtering, the I'm not sure how to call it anything except filtering, the sampling or the anti-aliasing. We can set that actually per render pass, which is a little bit interesting. These are some videos showing like some of the interesting things you might do with Z and P and normal passes and all of that. And one quite funky thing you can do in Nuke is to actually use those passes to relight your scene. So if you have the position and you have the normal, then you can actually set up in Nuke a very simple 3D scene and to add lighting to the scene. And it's a little bit uh, funky, but it works. Not sure if this. Oh yeah, so they sort of added a little bit of a hit here, a little bit of a rim light. Not sure if they make that more extreme. Yeah, they make that more extreme. So that's quite interesting that you can like push your lighting even further, like after you rendered, and then you realize that, oh, I wish I had added a rim light instead of going back to Maya and re-rendering for 5 hours straight. You can just do that in Nuke, which is quite handy. Also adding things like ZD focus, we'll get back to that one, but adding in stuff like fog and things like that just become way easier to do in Nuke than doing them in Maya. Or it's pretty straightforward to do it in Maya, but it just means a lot of rendering. And yeah, finally, we can also create custom AOVs, or well, maybe AOVs where we have to spend a little bit more effort. And the first part of this category to me is adding in per light AOVs or light groups. So basically, on each light in Maya, we can actually write in and we can give it a name, or we can, yeah, yeah, give it a name, and that will be its group. And then we can add other lights to that group, and we can have different lights and or light groups. And then if we, you can check out the workflow here. I don't need to go through it. You can check out the workflow, but basically we can split out each light to its own AOV. So this is the composite version of everything, and then yeah, just split it out, and that gives you total control over your rendering in post. And I know, and I used to work this way myself. Like one workflow for lighting is to essentially not care that much about how it looks in Maya. Just add in a light, any kind of light that's sort of roughly in the right position, or it should be in the right position and with the right angle. But when it comes to managing the intensity of it, like don't even bother. You can fix that in post, and um, that's one way to work. I these days I'm a little bit more nerdy and I try to make everything as correct as possible in 3D and not fix things in post, but it's an interesting workflow to do. I mean, I didn't even used to set the color of my lights. I would just have everything the same color and then just tweak that in Nuke and it would work perfectly fine. But that's sort of maybe if you're in quite of a rush and you don't have the time to spend too much like, well, time on tweaking stuff in Maya. Something else we can do, like we can add all kinds of strange custom passes. So maybe you can check out this video or this article if you want more details on how to create custom AOVs. And one example is just to create an UV pass. So UV pass is just a render, and I like to do this quite a lot, is a AOV that basically shows the UVs. And it will look something like this, green and red and yellow. And that just shows you the UVs or the UV values of the stuff that's being rendered. And you might ask, okay, well that's great. What do you do with that? And actually, if you do that, you can retexture your scene in 3D or in comp. I mean, in 2D, you can retexture it afterwards. So this is actually, I think this is in Korean or Japanese or something, but just sort of shows you what you could do, where you have a UV pass and well, adding in a bunch of blood and stuff to this alley as a doing it in comp, and this can be quite a time saver to just apply a texture like this, and like it's stuff that you realize like, maybe if we check out the final result. So we have this. I think this is the blood, and then if we had the same scene in the beginning, um, do, do, um, I think it's a little bit more clean, right? Ah, maybe a little bit unclear, but also like you could animate these textures in comp and do all kinds of weird things that would be sort of risky to do in 3D because it's sort of slow to do in 3D and it might not be clear what's going on. Whereas if you just do it in comp, you have total control. I mean, it starts to slow down, of course, eventually, but not as much as if it was done fully in 3D. So, yeah, moving on a bit, I would like to talk about depth and taking that a little bit further. So, we talked about, well, we didn't really talk that much about C depth, and C depth can be used. I mean, it's just a black and white image of like the depth in your CG render, right? And a really common thing to do is just like adding in, like in comp, just add smoke and dust and little subtle effects that you like. Sure, you could like simulate 3D smoke, but it's really slow. And why would you when you can just download a nice stock footage of it instead? So here he sort of shows how to add that sort of smoke in using a depth pass to sort of mask that smoke and make it look a little bit more natural um, when adding in uh, adding this. Like this is the stock footage element that before was it doesn't actually have any depth information, but it can look a great deal more interesting if you do it that way. Um, and we also mentioned like adding, if you add the position and maybe also the normals, you can start doing really weird stuff like relighting. Just reference that now it's 2009. It was District 9 that sort of made this workflow really appear, like one of the big early ones, which is like if you have the position rendered to a pass, you can sort of get your 3D scene. Um, you can recreate it and sort of use it as a guide for where to place out things like dust, foot dust, and all kinds of weird things, which is a quite handy workflow, and they sort of show how to take that quite far. So that's all good and well with like using the C depth or the depth of the rendered depth as its own image, but using that to sort of well, do all kinds of weird things. Something you can do to take that way further is um, rendering deep samples or deep EXRs. So seed depth and position and all that. I mean, that's still an image, right? It's just an image where each pixel has a value that represents the depth. So you can see the depth, but just within like just what the camera can see, right? Whereas deep EXRs or deep rendering actually means taking multiple samples in depth. So you don't just render the front side of objects, you render the back side, and then you render the thing that's behind that. So you're actually rendering a lot of stuff that you don't necessarily see from the camera. And that's deep compositing. And why would you want to do that? Well, maybe because you want to do all kinds of weird things. And one example was is here. You can find it somewhere here. Uh, well, when rendering things like fluids or smoke and stuff in 3D, rendering that with deep samples is quite nice because then you can sort of place things into the fog or into the smoke, and it will just look a great deal more natural. So that's really mostly I see this used for fluids and things like that. But also a sort of fun example. I'm not sure if it's here. It's the Planet of the Apes. They actually render all these apes with the deep samples, and you can sort of think of the apes as a big fluid of apes, and then if they wanted to control like an ape that's sort of like maybe behind another ape or something like that, or maybe they decided they wanted to cut out a monkey that was blocking another ape, with deep samples, you can do that sort of stuff, which is quite interesting. Of course, the files itself becomes huge because you're rendering multiple depths everywhere. But it's sort of a cool workflow. But cool workflows aside, and this is another example really of cool workflows. It's just if you got time, you can check this out. Compositing magic tricks, and it's maybe some of it is a little bit too much about compositing, but there's a few ones here about things that might be relevant to you. But it just goes to show that you can really do pretty much anything in comp. But some of the base things would be, well, just color correcting things and adjusting or adding lights. But also, like, you can start denoising things. Like if you have, yeah, noisy renders, you can denoise, do custom denoise, all kinds of weird things. This Arnold Arvid Schneider, it's Arvid talking about Arnold, um, goes into denoising and also using Nuke and actually a custom plugin to Nuke to denoise, and that's nice. And sometimes, like when we render stuff, or sometimes things just bug out and we get render artifacts for no apparent reason, or maybe it's not even artifacts, it's just that we render stuff and realize that we shouldn't have done it that way. And this is actually a video that shows wire removal. So like a very classic uh, compositing or paint job is like having to remove wires. But we can think of wires as pretty much any element in an image that we want to remove. Um, and this sort of shows you how to do it, how to clone that sort of stuff out. There's also like slightly more magical analytical tools that sort of use AI and whatnot to try to remove annoying objects. But it's good to know how to do cloning. I mean, it's just the same sort of cloning you would do in Photoshop, but on filmed material. Because then if you ever render something and you just something annoying happens, or maybe you forgot a cube and you have a cube floating somewhere in the background of your render and you just want to get rid of it, well, use Rotopaint and just clone it out. I mean, just fix it. It's yeah, that would be an option for you. So yeah, moving on to camera and atmospheric effects. And yeah, adding this sort of stuff tends to create far more believable images. 3D rendering only goes so far, but taking a little bit of an extra step often yeah, adds something quite important to the image. And well, this isn't. I'm not sure why that one is there. This isn't really an effect as such. This is just a quick note about cameras and the way actual cameras and actual movie sets are physical beasts that are there and can't really be just imagined away and work in certain ways. And even if we can do anything with the camera these days, maybe we shouldn't, because the cinematic look or the cinematic convention of a camera and how a camera should move in a cinematic way is quite fixed. And I like to bring up the example of I've shown this before, so I won't go show the whole thing, except it's not really that long. It's just this camera movement in from the early Lord of the Rings, and Jesus, this is low quality, I guess. Oh, okay. Uh, where it is a long camera movement and it does all kinds of stuff, but it's I guess a really real camera, and we really feel it, right? We can feel it as an audience that it's a real camera and it just feels real. Um, it almost brings a little bit much attention to itself. Camera movement generally should be just sort of invisible. But then we have the Hobbit movies that are just swarming with camera movements, and they're all so fluid and they're all so perfect and they're all just floating around and doing all this magical stuff. And it just immediately becomes obvious that everything is 3D. Like even when not everything is 3D, oh goodness, this is such a 3D shot. Like this would never have happened with a actual camera. Very little of this would have happened with an actual camera because it's just a random camera movement for no particular reason. Um, Normal cinema would have probably had that as two different camera shots. So, yeah, thinking about how we use or what camera um, you use and how you use it. But then it comes to more to camera effects, and again, this tutorial here goes into more detail, and I find it was quite good. So that's well worth checking out. Otherwise, that's sort of the stuff that um, things like this book sort of talked about. Though to be honest, this one sort of covers everything this one does. So maybe don't even go read that book. Everything is available online these days, so just check that one out. But I like to think about camera effects, or what I call camera effects. Uh, I sort of split that up into three points, and that's scene effects. So it's not really camera at all. That would be dealing with things like atmospherics and halos and stuff that we might not immediately realize as part of a scene, or we might not think of it. If all we think about is, okay, so we have the scene and we have these objects and then we have these lights and then bam, that's the scene. That's sort of forgetting the atmospherics, and a very like the most obvious of this being depth haze. Reshade? No, just depth haze. And yeah, like fog essentially, but this type of or some sort of depth haze is visible everywhere. Then I like to so scene effects, that would be one step, sort of what happens before the camera, and then lens effects, what happens inside the physical lens, where all kinds of weird things happen. For instance, lens flares and also vignetting and things happen. And then I like to think about media effects, which is the capture media, and then we get grain and halation and various sort of things. And it makes sense thinking about it in this order because this is also the order in which we want to add them to make sure that, um, like, to make sure it makes sense, right? We would want to, like, really, the grain is the last thing that happens most of the time. So the lens flares should have grain, not sort of floating magically on top of it, for instance. Even though like the intensity of light sort of affects how visible grain becomes, but that's just a question of doing the grain portion correctly. So that's what I sort of consider as camera effects, and some camera effects are actually controlled or controllable in Maya uh, on the camera itself. So making sure you have an appropriate um, maybe that's not even shown down here, but the focal length of the camera, obviously that's an important aspect of the camera. Not just having every camera being the Maya default of, I think it's 35 millimeter. But we can also change things like focus, and if we want to render things like the bokeh directly in Maya, then we can do so, but that's actually a different slide, so I'll leave this one alone for now. And let's talk about depth of field for a little bit. And just so we're all on the same page here, depth of field is the area which is in focus, and if it's not in focus, then we start getting blurred. Yeah, portion of the image will be blurred, and these in real cameras, the depth of field is it depends on how big of a aperture, how big the aperture is. So if it's a small number, it's a big aperture and it will have a quite shallow depth of field, whereas small aperture equals a deep depth of field. So an interesting point here is that in reality, uh, having the size of the aperture itself will of course affect the exposure as well. Of course, you can adjust for that in uh, reality in the camera. Maybe you'll increase the ISO or something else to sort of maintain the same exposure. It's just, well, sort of an interesting point that that's how it works. Anyways, so let's see. So the depth of field, obviously quite important, is to set the focus depth if we're going to apply a depth of field, which is generally always a good idea. really in CG to just always have depth of field of some sort, even if it's quite subtle. Just it adds that level of realism. I mean, that's the whole reason why we're talking about these camera effects, is like even having just a little bit, a little very, very subtle amount of any of these will add a lot to the image. So yeah, having focus depth important. If you ever wonder about the bokeh, it's actually like if you, well, I can't zoom in further, but the way these apertures actually work are these tiny blades that close in, and that's sort of what determines the bokeh effect. Or I think we could see it over here. No, we couldn't see it over there. I guess I'll just click this link, and this shows you. It's really the question of how the blurred out versions or the blurred out portions of the image, how they are blurred out, which shape they are blurred out. And like we don't necessarily just want to accept the default blur that the default settings give us, because the type of bokeh is quite a can be a quite important artistic choice, really, for a proper cinematographer. Anyways, so in Arnold, enabling depth of field, I mean, it's not that complicated. There's a checkbox, enable depth of field, and start rendering with it. We'll immediately notice that things get slower. We'll just need a bunch of more samples to blur things. You'd think it would be easier to render things when they're blurred, but it's the complete opposite. It becomes harder. So, well, this tutorial sort of covers the basics of setting that up in Arnold. Quick note or a quick tip when working with depth of field and maybe animating depth of field is that the to set the focus depth, like in on the camera, it's just a slider, it's just a number, and it's not a very convenient way to work, really. So the typical way to work is shown in this video, and it's to actually set up a distance or a measurement tool. I'm not sure if it's when it's shown. It doesn't really matter. This guy will show how to set it up, and basically make it so that you can control or animate the exact position of the depth of field. I won't go into myself. It's just check out that video if you need to have fine control over the depth of field. And he shows that just for my app, but this little note should be enough to cover it for Arnold as well. But because it's quite slow to render, it used to be quite common to do this in comp instead. These days, I think most people just sort of render it in, sort of do it anyways. But it depends on the company. It depends on how much time you have to render. And sometimes it's just good to know that you can do this sort of stuff in post as well, because, well, suddenly you find strange uses for it, and it's just sort of nice to be able to add that level of control. So what you can do is, well, if you render the C depth, and this is a point where you would maybe want to make sure that it's in 32-bit, and the filtering is like, you'll maybe notice that the default option when you render in Z depth is that it's not filtered, that it's not anti-aliased. And the reason for that is to make sure that the Z defocus tool in Nuke, that's what it's called, like that's the node that you use to set up your like focal plane, and that generates the blur. For that to work correctly, it needs to not be filtered. It just sort of becomes strange when you have like intermediary values that, yeah, it becomes strange. So that's the reason why it's not filtered. You can read about the actual like how to hook things up portion here. It's quite straightforward, and that's how it works. A thing to note, though, is that like for this to work perfectly, ideally, like every object would be on its own layer, because when you blur things, or well, what happens when focus blur happens is, well, things are blurred, but they're blurred in an optical way. So you actually, like, you get pixels from, for instance, like between behind objects sort of become a part of the final image, right? But if you render a sort of flat image and then blur it, then you can't really do that. So something you might find yourself needing to do if you're going to do this, like as a, like, make sure that there's no artifacts or anything, is to start splitting your render into layers using render setup. And maybe I did, this is really ugly. I just sort of did a little bit of photoshopping. I couldn't be bothered to make my own scene. So you'd maybe render your background as one layer, and maybe each ball that's not overlapping as its own layer, and then the ball that was overlapping the blue ball as its own layer, and then blur them each separately and then merge them together. And that would be sort of the perfect way to do it. Quite often you don't really need to do this. Like in theory, you there are some artifacts, but it looks good, and if it looks good, it is good enough. So that's just um, the sort of theoretically proper way to do it. But don't do it unless you don't need to. The other key camera effect is motion blur, really. So motion blur being, I don't know, when things that move get blurred, sort of makes sense. Which again, in reality, is really dependent on the shutter speed. But for film cameras, that's pretty much always a set speed. And in in cameras, or well, so the way most cameras work, right, is they would film the scene in, say, 24 fps or whatever. Maybe you have some other speed on your camera, but 24 being like a filmic standard. And then the next question you ask yourself, so for how big a portion of 1/24th of a second, for how big of a portion is the shutter actually open? And usually it's not open the entire 1/24th of a second. Often it's, or sort of the default assumption is often that it's open half of the time. So effectively speaking, the camera for a 24 FPS movie has a shutter speed of 1/48. Anyways, this fact that it's open only half of the shutter, or the FPS, that's often represented in terms of degrees. So 180 degrees, that's half a circle. So that would be a 24 camera being having a 48 shutter speed. Um, but you can find cameras with other options as well. But it's just to be aware that this is often expressed as as a um, as a fraction or as degrees rather than in terms of shutter speed. And I believe in Arnold, like you can, this is the effect we're going for. Uh, you can control it like shutter angle 180 degrees, but it says here length 0 0.5. And as you adjust that, it should update the shutter angle, and the 0 0.5 here is like half of the frame. So you control the amount of motion blur basically by increasing this number. So yeah, this is the documentation for all that. And yeah, if my explanation was confusing, then check out the documentation there. And yeah, of course, also with motion blur, again, blur will slow things down for the renderer considerably. So also for motion blur, there's a comp solution, and that's called rendering out a motion vector AOV pass, which uh, I'm not sure they have an image of it. It tends to sort of look quite abstract. Yeah, they're not even showing an image of it. It's just a bunch of colors that basically show, okay, yeah, all right, yeah. So in this image, it shows like in what direction the like this pixel in what direction it should be moving, uh, which looks a bit abstract, but that's how it works. And like what you do is in Nuke at least is using a vector blur node, basically the way they describe here, and then you get motion blur. Excellent. But what you notice here is it becomes perhaps even more important to actually render like just the stuff that's going to be motion blurred in its own layer and static objects in their own. So it can become a little bit finicky, really, to split up your render in order to do motion blur in this way. But again, it's good to know that the option is there because suddenly it becomes useful. A sort of a poor man's version of this is to let Nuke or your compositing software do an optical flow analysis of your scene. Let's say you rendered a scene without any motion blur applied, and then you realize, oh, should have had motion blur. Then you let Nuke analyze it and basically do a best guess and sort of try to do its own version of motion blur. And I don't need to go into it. If you ever need to fake motion blur and just hope for Nuke to do it for you, then check out that video, and it will most of the time do a decent result. I mean, it won't be correct necessarily, but if it looks good, it is good. And I'll close things up with a discussion about atmospherics. And atmospherics being anything that's volumetric, like fog and whatnot. And in the Maya tutorial, uh, you did get an introduction to a basic way of doing that in Maya, just adding an atmosphere and sort of having it everywhere. But of course, we can become more specific with that. And I won't go into any kind of detail here because volumetrics can become really it's a big topic. Like suddenly you're simulating clouds in the sky, and it can become quite heavy. But as you notice, it can also be quite easy to just add in an atmosphere. Another thing you can do is just add in a plane, like literally just have a plane and just apply a fog texture on it. And maybe if it's a video, you can have a like a stock footage video and just have that in Maya and have it on a plane. And if it'll be two-dimensional, but if you place it right, it'll probably look quite nice. So that's another option for you. Another option could be, or something you might want to be able to do, is to have dust particles floating around in Maya. And particles can be created in all kinds of ways. And this guy will sort of give one really maybe a bit too detailed example of how to create dust that just floats around. And this tutorial will go on to put this into toolbag. Yeah, Marmoset toolbag. No need to do that. I mean, if you get to this result and you just hit render and maybe give it, these are actual small objects, little balls. Um, just give that a decent texture or material and just render it, and that will probably look quite decent. So that's another option for you. But to continue my sort of theme with comp, much of that becomes simpler to do in comp. So if you have the seed depth, adding depth haze is as easy as pie. It's just a bit of a color correction and just adding it on top, really. But also all kinds of particle generators and volumetric effects and such are available in Nuke. So already mentioned this tutorial, which is about like using stock footage, but can also mention this tutorial, which is quite nice, about adding in like God rays and stuff like this into your scene. And doing something like this would be quite slow and laggy in Maya and Arnold, but in Nuke it's just plug and play, really. And this tutorial also goes on into like adding particles and all kinds of things. So this is a quite quite interesting thing to check out, and in my opinion, easier to control than sort of doing it correctly or doing it in Maya. But it all depends, of course, on what you try out and what you become familiar with. And that wraps things up. So my main point here being, like, don't just settle for a final render. Go a little bit further and think about a final image instead, and that's what we're going for here. So thinking about the lighting, well, really thinking about the lighting shouldn't be skimmed over. This is the part where you should like really make sure you have a good plan, finding a good reference, and having a clear vision, clear like idea of how this will work from an art principle perspective. Um, that would be like without that, it, it just becomes annoying. But anyways, we talked about lighting principles, some of the tools, using textures on lights being a quite nice trick. But of course, there's a few other ideas about approaching lighting in a systematic manner. Again, I suggest you read that CG cinematography website for details on that. We talked about render wrangling, and honestly, most of what you need you'll find in this render setup tutorial and in these videos that'll sort of get you going with the practical work of rendering things. We've talked about AOVs and sort of gotten started with the idea of CG compositing, and maybe like the number one stop thing that you want to accomplish with CG compositing um, would be the camera effects and things like depth of field and motion blur. Sure, you can do them in 3D if you want, but things like atmospherics and things like camera effect, like lens distortion and grain and lens flares, that stuff you will need to do in comp.